November 30th, 2025. It began with a quiet data release, a routine update from the Hubble Space Telescope archive that would soon ignite a firestorm of debate across the scientific world. NASA just dropped a fresh, breathtakingly clear image of the object known as 3I Atlas. And the celestial body that a vast majority of astronomers had comfortably labelled as just another comet is now doing something that comets simply are not supposed to do. The image is stark, and the anomalies are immediate, visible even at a first glance. At its heart there is a tight, impossibly concentrated and stable core, a single point of light that refuses to yield to the immense forces acting upon it. But streaming away from it in the wrong direction is an enormous anti-tail, a luminous trail stretching for 60,000 kilometers, pointing directly at the sun. As if that wasn't enough to rewrite textbooks, hidden within the data, visible only when powerful enhancement filters are applied, are two perfectly distinct jets firing in opposite directions. And here is the part that elevates this from a mere scientific curiosity to something far more profound. The exact shape, the precise length, and the sunward position of that anti-tail match, with unnerving accuracy, a prediction published by Professor Avi Loeb. He published his paper, his detailed model, before this image was ever taken. I want to be clear about this point because it is the crux of the entire matter. This is not a case of a theory being loosely adapted to fit new data. This is a specific, quantitative prediction that has just been vindicated by observation. The match is not close. It is, by every measurable standard, exact. As this bombshell was being processed, a second, crucial piece of evidence emerged from an entirely different part of the solar system. The European Space Agency's JUICE probe, on its long journey to Jupiter, happened to capture the same object from a completely different, much wider angle. Its data revealed features that Hubble's tight, focused zoom had completely missed. A clear separation of the plasma tail from the dust tail, distinct layers within the dust itself, and undeniable evidence of active, ongoing outflow. If you have been following the strange saga of 3I Atlas, and if something deep down has felt off about the official, simple comet story, then you are not alone. The data is starting to tell a different tale. Hit subscribe right now, smash that like button, and let's break down the new Hubble data, the stunning confirmation from the JUICE probe, and the scientific prediction that just came true. We are going to walk through the evidence piece by piece, because the story of this object is becoming one of the most important scientific mysteries of our time. This is exactly why you clicked. Let's talk about context, because in astronomy, context is everything. When the Hubble Space Telescope turned its powerful eye towards 3I Atlas on November 30th, 2025, the object was located approximately 286 million kilometers from Earth. More importantly, it was about 1 month past its perihelion. Perihelion is the moment of closest approach to the Sun, and for a comet, this is the moment of maximum trial by fire. It is a period of unimaginably intense thermal and gravitational stress. For an object made mostly of ice and dust, this is a violent, chaotic event. The Sun's heat should be boiling its surface, causing the nucleus to fracture and crack under the strain. The outgassing of vaporizing ice should be uneven and chaotic, erupting from fissures and weak points on the surface. This process creates asymmetric jets that act like tiny, unpredictable rocket thrusters, causing the comet to tumble and wobble. We would expect to see the formation of fragmented debris clouds, pieces of the comet breaking off and trailing behind it. So, what should Hubble have captured? Based on every comet model we have, it should have seen the aftermath of this celestial violence. It should have photographed an object showing clear signs of coming apart at the seams. We should have seen cracks, splits, and a nucleus that was elongated or even broken into multiple pieces. We should have seen a messy, lopsided coma, the glowing atmosphere around the comet, indicating that material was being ejected unevenly. This is the established, accepted theory of post-perihelion cometary behavior. It is what we have observed time and time again with other comets. But what Hubble actually observed was the complete and total opposite of this expectation. It was a portrait of unnatural, almost defiant calm. The core of 3I Atlas, the very heart of the object, is where the contradiction is most glaring. The image shows it as a sharp, intensely concentrated point of light, perfectly holding its center of mass. There is absolutely no sign of elongation, no hint of splitting, and no signature of any off-axis drift that would suggest it was tumbling. The specific instrument used for this capture was Hubble's Wide Field Camera 3, using the f350p filter, a configuration highly sensitive to structural details. If there were significant internal fractures or multiple fragments clustered together, this camera setup would have exposed them, but there are none. The center holds, perfectly and impossibly. Then there is the coma, the vast, glowing cloud of gas and dust surrounding this stable core. It spans a diameter of roughly 40,000 kilometers, and it is beautifully, eerily smooth and symmetric. The glow is expanding evenly in all directions, like a perfect sphere of light. There are no obvious directional plumes, no messy trails of debris cutting through the uniform cloud. It is just a massive uniform halo radiating outward from a core that refuses to break. This presents a fundamental contradiction that we cannot simply ignore. Our standard models of cometary physics predict chaos after a close pass with the Sun. Yet, 3I Atlas is exhibiting an extreme, unprecedented level of stability right at its core. It survived its trial by fire, not just intact, but seemingly unfazed. This is not what comets do. They fracture, they shed material unevenly, and they show the scars of their journey. This object, however, is holding itself together far better than any of our models ever predicted it could. The image is critical because it forces us to question our most basic assumptions. Is this an entirely new class of object, or are our models of how comets behave fundamentally incomplete? While Hubble was locked in a tight, focused gaze on the inner core, the ESA's JUICE probe, by a stroke of cosmic luck, captured the object from a much wider perspective, and the picture it painted changed everything. It's important to understand that JUICE was not using a dedicated, high-powered science imager for this observation. The camera that caught 3I Atlas was a navigation camera, a simpler instrument designed primarily for guidance and orientation, not for deep space research. Its wider angle of view, however, allowed it to capture the larger environment around the object, the very context that Hubble's narrow zoom was designed to miss. And even with this non-specialized camera, the resulting frame picked up two distinct, crucial features that completely demolished the idea of a simple, symmetrical object. First, the JUICE image shows a narrow, faint streak of light rising away from the main glow. This is the plasma tail. Let's break down the physics here, because it's important. The plasma tail is composed of ionized gas, atoms that have had their electrons stripped away by the Sun's intense ultraviolet radiation. Because these particles are now electrically charged, they are grabbed and violently pushed away from the Sun by the solar wind, a constant stream of charged particles flowing out from our star. This is why the plasma tail is always thin, straight, and points directly away from the Sun, regardless of the comet's direction of travel. What you're seeing is a live, real-time interaction between the object and the Sun, not just a trail of leftover debris. Below it, angled completely differently, sits a second, more familiar structure. It is broader, heavier, and more diffuse. This is the dust tail. The dust tail is made of larger, heavier particles, tiny specks of rock and dust. Because they have more mass, they are less affected by the solar wind and respond more slowly to the gentle push of solar radiation pressure. They tend to follow the object's orbital path, creating a curved, fan-like tail that lags behind. Here is why the separation of these two tails is so significant. When you see a distinct plasma tail and a distinct dust tail separating like this, it is direct, unambiguous evidence that the object is actively releasing fresh material. It is not a passive, inert rock coasting through space. It is a dynamic system, shedding both gas and dust right now. The plasma tail forms from the gas being ionized, while the dust tail forms from the heavier particles being released. They are governed by different physical forces, they move at different speeds, and as a result they split apart at different angles. The fact that JUICE, with its simple navigation camera, caught both of these structures so clearly in a single frame, even against a dense background of stars, means the outflow is significant. Hubble didn't see this because Hubble was zoomed in too tightly on the inner region, focusing on the core and the immediate coma. JUICE, by chance, caught the wider, more dynamic view. We now have two spacecraft observing from two different angles, telling us the same incredible story. An object with a mysteriously stable core on the inside, but with dynamic, active and complex material being shed on the outside. The calm at the centre is powering a storm in its wake. Now, let's return to that stunning Hubble exposure and see what happens when we use modern image processing techniques to look deeper, to peel back the layers of light. When you look at the raw, unprocessed image, it can be deceptive. It shows a smooth distribution of brightness, a clean and seemingly undramatic glow. It looks simple, but the moment you apply digital filters, that simplicity shatters and a far more complicated reality emerges. The first step is to apply a common technique called an unsharp mask. This filter is designed to enhance edges and subtle differences in brightness. The effect on the 3i Atlas image is immediate and startling. The perfect symmetry of the raw image breaks. The inner region of the coma is no longer a perfect circle. It now shows a distinct tilt, a subtle distortion. This enhancement suggests that there is an underlying, uneven outflow of material that was not obvious to the naked eye. The perfect sphere of light was an illusion. But the real revelation comes when you apply a more specialized tool, the Larsen-Second filter. This is a sophisticated algorithm specifically designed by astronomers to detect rotational gradients within a comet's inner coma. Its purpose is to find the hidden patterns of spin and outflow that are often washed out by the overwhelming brightness of the core. When this filter is applied to the Hubble data, the entire story shifts. Suddenly you are staring at two distinct, powerful jets erupting from the core. They are unmistakable. One jet flares out towards the sun, feeding material into the coma. The other jet pushes back in the opposite direction with such precision that it perfectly forms the clean, linear anti-tail we observed earlier. Anti-tails are not common features for comets. You do not usually see this kind of clean, sunward geometry unless the object is spinning in a stable, locked manner and releasing material in a very specific, controlled pattern. The filter, in essence, exposes the underlying engine that is driving all this activity. This structure is subtle in the raw image, completely invisible to a casual viewer, but once enhanced, the architecture of the system jumps out. You have two powerful jets firing in opposite directions and a spine-straight anti-tail pointing exactly where you would not expect dust to align. The only way to produce such a feature is if the object's rotation is stable, locked in, and consistent over time. This discovery ties everything together. It provides a direct physical mechanism for the separated plasma and dust tails seen by the JUICE probe. A stable spinning object with active jets would naturally create the complex multi-part structure that JUICE observed from a distance. We now have two different datasets, from two different instruments, processed in two different ways, all pointing to a single, unified conclusion. This object is active, it is directional, and it is rotating in a highly structured way that is not easy to classify as simple cometary behavior. And this is where the story becomes truly unsettling. This is where we move from observing a strange object to confronting a confirmed prediction that challenges the very foundation of the mainstream explanation. Before the Hubble Space Telescope captured that image on November 30th, Professor Avi Loeb of Harvard University published a paper. In that paper, he was not just speculating, he was modelling a specific testable hypothesis. He proposed a scenario where 3i Atlas was not just a single object, but a parent body that had released a swarm of smaller solid objects near its perihelion. He theorized that these fragments, perhaps probes or reflectors, would then separate from the main body and drift under the influence of non-gravitational forces, primarily the pressure of sunlight. His paper included specific detailed calculations. He predicted that by late November, these drifting fragments would have moved to a position closer to the Sun than the main nucleus. They would form a luminous trail, an anti-tail, with precise and measurable characteristics. He calculated that its shape would be like a teardrop. He calculated that its length would be roughly 60,000 kilometers. The new Hubble image shows exactly that. The anti-tail stretches 60,000 kilometers, a direct match for the predicted length. The teardrop geometry of the feature is a perfect match for his model. The position of the anti-tail, sunward of the nucleus, aligns perfectly with his calculations. Let me repeat this, because its importance cannot be overstated. This is not a vague similarity or a post hoc rationalization. This is a direct, quantitative, predictive confirmation. Avi Loeb wrote the paper, laid out the specific numbers, and described what we should see. Hubble then took the picture and the data matched his prediction point for point. Most scientists have been quick to dismiss Loeb's more unconventional ideas, especially his claims about non-gravitational acceleration. The standard rebuttal has always been that normal, chaotic, outgassing from a comet can explain any strange movements, but that explanation now faces a serious problem. Chaotic outgassing is, by its very definition, random and messy. It cannot produce a result that perfectly matches a precise, geometric prediction made in advance. If 3I Atlas were just a typical comet sublimating randomly, its tail structures should be more diffuse, more complex, and far harder to model with this level of accuracy. Instead, Avi Loeb calculated exactly where a cloud of released solid material would be, and the Hubble image confirmed it. That level of precision does not happen with random, chaotic comet behavior. It happens when the forces involved are predictable and follow controlled, well-understood patterns. The vindication of his prediction forces us to ask a difficult question. If the standard model of chaotic outgassing cannot account for this confirmed prediction, then what can? While the strange shape and behavior of 3I Atlas raise profound questions, it is the object's fundamental composition, its very chemistry, that deepens the mystery to an almost untenable degree. Spectroscopic studies, which analyze the light from the object to determine what it is made of, have revealed a chemical signature that is deeply puzzling. The data shows a nickel-to-iron ratio of approximately 10:1 in the observed metallic fraction of the material. This ratio is highly unusual and is far more akin to what you would find in sophisticated industrial alloys than in natural comets. Comets are born in the cold, outer regions of protoplanetary disks, the nurseries of solar systems. In these frigid environments, heavy metals like nickel and iron do not readily condense. Instead, these bodies are dominated by volatile substances, water ice, carbon monoxide, methane, all mixed with simple silicate dust. They are often called dirty snowballs for a reason. Heavy metals should only exist in trace amounts, never accumulating in concentrations high enough to produce such a strong, detectable metallic signature. Yet, 3I Atlas shows them clearly. The gas emission data only compounds the problem. Analysis of the coma reveals only about a 4% water content. This is a shocking number. Typical comets are believed to be 70 to 80% water ice by mass. The low water abundance, combined with the excess of metallic elements, creates a compositional profile that simply does not fit into the established category of a comet. It is metallic and it is dry, the exact opposite of a dirty snowball. This chemical anomaly is just the beginning of a cascade of strange properties. There is also a photometric anomaly, related to how the object behaves with light. It exhibits an intensely negative optical polarization, a rare and poorly understood phenomenon that does not align with the light-scattering properties of any known natural objects in our solar system. Then, there is the thermodynamic anomaly, a fundamental energy problem. The colossal jets we see extending for millions of kilometers, and the sheer amount of material being ejected would require an enormous amount of energy. The mass fluxes and the required absorption areas for solar heating far exceed what a nucleus of the estimated size of 3I Atlas could possibly support if it were powered by simple sublimation of ice. The numbers do not add up under the known laws of physics. Even more bizarre is the radiation anomaly. The object is emitting its own self-generated X-rays, not just reflecting X-rays from the sun. For a normal comet to produce its own X-rays, it would need to expel a massive amount of gas. This gas would then interact with the charged particles of the solar wind in a process called charge exchange, which can generate X-ray radiation. But here's the contradiction. 3I Atlas appears to be extremely dry, with minimal gas output compared to its size and activity. The observed X-ray emissions do not match the observed material output. The source of the X-rays remains profoundly unexplained. Add to this the kinematic anomaly. Measurements of the object's trajectory show clear non-gravitational acceleration, meaning its velocity is changing in ways that cannot be explained by the pull of the Sun and planets alone. In standard comet models, this acceleration is attributed to sublimation thrust, where gas venting asymmetrically from the surface acts like a small rocket engine. But this process requires visible mass loss and a significant debris cloud. 3I Atlas shows the acceleration, but without a debris cloud sufficient to justify the magnitude of the change. There is simply not enough visible material being lost to explain the effect. Finally, there is the orbital anomaly, a trajectory that seems almost suspiciously convenient. The object's path through our solar system includes successive close approaches to Mars, then Venus, and then Jupiter, an alignment chain that is extremely unlikely to occur by pure chance. Furthermore, its trajectory sits almost perfectly aligned with the ecliptic plane, the flat plane where all the planets orbit. This is statistically improbable for a random interstellar object, which should arrive from chaotic, dispersed angles. To cap it all off, if you trace its path backward, its apparent point of origin in the sky coincides with the region associated with the famous WOW signal of 1977, a powerful, unexplained radio signal from deep space. It is a coincidence that is unsettling even to those who reject the most unconventional explanations. The scientific community is not standing still. The next few weeks promise a flood of new data that could either solve this mystery or deepen it even further. NASA has promised to release the full Hubble dataset soon, and the most anticipated part of this release is the ultraviolet spectroscopy. This is data gathered from light that our eyes cannot see, and it is one of our most powerful tools for determining the precise gas composition of the coma around 3I Atlas. This data could be the final arbiter. It will tell us if the molecular ratios of different gases fit within the known chemistry of natural comets, or if they point to something else entirely. If the UV spectra were to show unexpected elements, unusual isotopic ratios, or concentrations of molecules that do not match any known comet reservoirs in our solar system, the entire conversation would shift permanently and irrevocably. Meanwhile, the ESA's JUICE probe continues its mission, and its suite of advanced instruments promises to deliver crucial data on composition, particles, and spectra. A key goal for the JUICE team is to analyze the anti-tail and determine if it contains solid, macroscopic fragments, as Avi Loeb's model predicted, or if it is composed merely of fine gas and dust. If JUICE can confirm the presence of solid objects within that tail, it would be a revolutionary discovery, changing everything we thought we knew. This ongoing investigation is a perfect example of science in action, driven by testable predictions. The mini-probe hypothesis, the idea that 3I Atlas released a swarm of reflectors or scouts near perihelion, provides a series of clear, observable events we can watch for. The theory predicts that the object's visibility should vary with specific orbital events. It predicts a sharp drop in visibility around December 19, 2025, followed by a significant resurgence in brightness near its encounter with Jupiter on March 16, 2026. These are not vague ideas. They are clear, falsifiable predictions with specific dates attached. If the observations match these predictions, we will be looking at a qualitative leap in our understanding of this object. If they do not, then the more conventional natural explanations will gain significant ground. Either way, the next few months will be critical. They will determine whether 3I Atlas remains a fascinating but ultimately explainable outlier, or whether it becomes the first confirmed example of a category of object that we did not even know existed. The evidence, when taken as a whole, does not demand a single, simple conclusion, but it absolutely demands a radical re-evaluation of what we are looking at. Let's synthesize the mountain of evidence we have discussed. We have X-ray emissions from a seemingly dry object. We have a metallic composition that defies cometary chemistry. We have a bizarre anti-tail geometry that points directly at the Sun. We have non-gravitational acceleration without sufficient mass loss to explain it. We have a specific quantitative prediction from Professor Avi Loeb that came true. We have direct observation of plasma and dust tail separation, confirming active outflow. We have enhanced images revealing a locked, stable rotation with powerful jets. And we have an energy budget that seems to violate the laws of thermodynamics. While any single one of these anomalies, taken in isolation, might have an exotic but still natural explanation, when you see them all together in a single object, they form a consistent pattern of contradiction. This pattern does not resolve cleanly within the established comet framework. The pieces do not fit. We are left at a profound crossroads, facing two equally staggering possibilities. The first is that we are witnessing the absolute limits of our current scientific models. Perhaps 3I Atlas is a natural object so strange, so exotic, that it will force us to rewrite our understanding of planetary science and astrophysics. The second possibility is that we are witnessing the arrival of something that does not fit our models, because it was never meant to. So, here is the central question I leave you with. Do you think the new Hubble data and Avi Loeb's confirmed prediction are enough to prove that 3I Atlas is more than just a comet? I want you to think about the evidence presented and drop your theory in the comments below. Be sure to subscribe so you do not miss our analysis of the upcoming UV spectroscopy results, which could be the key that unlocks this entire mystery. And finally, share this with someone who needs to see it, because the next data drop from the void could change everything we thought we knew about our place in the cosmos.